So in the next two lessons, we're going to talk about some more identities. Okay. And these are ones that you will get on your formula sheet. And these are all for the provincial exam. So we talked about reciprocal identities. Can somebody give me an example of a reciprocal identity? 10 equals
y over x, or sine of the both.
That's a quotient identity, but it is an example of an identity. Okay. Are you just reading it?
It's difficult.
So a quotient identity is 10 is sine over x. What's a reciprocal one? 1 over. Okay, give me something that's 1 over. What cosecant is 1 over sine? Secant is 1 over cosine. Okay. Give me a Pythagorean identity without just looking at it. If you're going to look at it, don't say anything. Somebody's saying it. Sine squared theta plus cos squared theta equals 1. Okay, the ones we're going to talk about today are sum and different identities. And like I said, these are kind of complicated, so you get them all. Okay, it's just a matter of knowing when to use them. So for example, if I take the sine of two angles being added together, that's the same as taking the sine of the first times the cos of the second, plus the cos of the first times the sine of the second. If I take the cos of two angles being added together, it's the same as multiplying the coses of each angle, subtracted by multiplying the sines of each angle, and so forth. Like, if I take the sine of a difference between two angles, that's the same as taking the sine of the first times the cos of the second minus the cos of the first times the sine of the second. So really, it's just a matter of recognizing that it's a sum or difference question and using the appropriate formula. That's really what it comes down to. Okay. So for example, and you could be given an expression that's expanded and asked to write the compressed form. Or you could be given the compressed form and asked to expand it. So for example, this one, okay? You need to go up to your formulas and see, okay, which one is this? Is it sine, cos, or tan sum? Or is it sine, cos, or tan difference? Well, it's not tan, obviously. It's not one of these. So it's going to be one of these four. Which one does it look like? Which one of these four? Is this one, right? Because we've got cos cos minus sine sine. So what's another way to write that? What's the compressed way? Cos of, well, what are the angles? Pi over 12 plus 5 pi over 12. But I could keep going. Can't I add these two together into a single angle? What do I get? 6 pi over 12. Or, what's an easier way to say that? And don't I know how to find that? What is the cos of pi over 2?
So we use the brackets. I would call plus 5.
Yeah, because this one, notice it's cos minus, so that's the same as cos adding those two angles. Yeah, so it's this one here. What is the cos of pi over 2?
Oh, I'm 0.
Looks like we're all getting to the right answer now. Yes, 0. Because remember, pi over 2 is up here at 0, 1. Okay? So notice we were actually able to find this without having to use a calculator. Because the only way we know how to do pi over 12 is using a calculator, because those aren't angles on the unit circle. We do this next one in a similar manner. Which one is this? Sine cos plus cosine. Sine cos plus cosine. First one, right? Sine sine. Okay. So here I'm going to write this. So this is cos sine. This is sine sine. So what's the compressed way of writing that? Sine of pi over 12 plus 5 pi over 12 again. Which we can add the two together to make 6 pi over 12, or similarly sine of pi over 2. What's the sine of pi over 2? 1. Okay? Okay. What?
We did different numbers. And the previous.
Wait.
What? What's that? All right. Yeah, no, it's me. It's not you, it's me. Okay? Yes, it's sine, what the heck, 5 over 9. What am I doing? All right. Yeah, we got a little work to do here, sorry. Can I add these two?
X6. The first one.
Times 6 on the first one?
Yeah, because we're trying to get to the, oh, not 6, 4. 4.
Yeah, multiply the first one by, let's make common denominators. So if I multiply the first one by 4, top and bottom. Now I can add the 2 to get 9 pi over 36, which I can reduce. Pi over 4. And what is the sine of pi over 4? I'm hearing it. Root 2 over 2. Good. Okay. So that's one type of example you could see where you're given a sine, cos, or tan sum or difference identity in expanded form. You're asked to compress it and then figure out what the value is. The second type, you're given the compressed value and you have to expand it. Right now, we don't know how to do these ones. These are not on the unit circle. But we can actually do them using the sine, cos, and tan identities. Okay? I need to think of two angles on the unit circle that add together to make 7 pi over 12. Okay. Think of all the angles we've got. What are the angles on the unit circle that we're familiar with working with? Let's start in quadrant 1. Pi over 3. What is that over 12? 4 pi over 12. Give me another one. Pi over 4. What is that? Give me another one. Pi over 6. 2 pi over 12. How about pi over 2? And if necessary, I could go into the other quadrants. I could do 2 pi over 3. I could do 3 pi over 4. But right now, I converted them all to 12. Can you take any of these two, add them together, and get 7 pi over 12? Yeah, these two. So isn't this the same as cos of 4 pi over 12, which is pi over 3, sorry, pi over 3 I should be writing, plus pi over 4. Why did I do that? Because I know how to work with these angles on the unit circle. Okay? So this is the same as this. Now let's use our formula sheet again. This is the cos sum one, right? Because it's cos at, how do I expand this out?
Cos A, cos B.
So it's cos minus sine. So it's cos pi over 3, cos pi over 3, pi over 4, minus sine pi over 3, sine pi over 4. I know how to find all of those using the unit circle. So I can actually find the values. What is the cos of pi over 3? Thinking of your unit circle. Root 3 over 2? Isn't that 1/2? What's cos pi over 4? And I need to multiply those together. Minus, what's sine pi over 3? 3 over 2. And sine pi over 4? Root 2 over 2. Well, when I multiply these two together, what do I get? Root 2 over what? 4. Minus. What's root 3 times root 2? Root 6 over 4. So I could leave my answer like that, or I could make it a single fraction. Root 2 minus root 6 over 4. Either one is acceptable. But I can't subtract root 2 and root 6. Okay. Using the same ones,
Remember, you don't necessarily have to find two angles that add to get pi over 12, because you can't. Can you find two angles in here that subtract to get pi over 12? Okay, so notice we got some choices here.
So Sonia said pi over 4 minus pi over 6.
That'll work.
Somebody else said pi over 3 minus pi.
Pi over 4. That'll work too. You can pick either one. Okay, and it's going to work out to the same answer. Yeah. Use the same angle twice?
Like if it was,
Yes, but that would get you 2 pi over 6, which is pi over 3, which we know how to do. Yeah, that's usually what happens if you use the same one.
okay, let's do this one. Let's do sine pi over 4 minus pi over 6.
Let's do that one.
So what have we got? Sine difference.
Going back, what is the expanded form of sine difference? Sine cos minus cosine,
Right? So sine of the first one times cos of the second. Sorry, I need some space here. Minus cos of the first times sine of the second. When you see
a question like this, like I strongly suggest you start writing these out off to the side, just to have as a guide. Okay?
which we can actually do. The sine of pi over 4, well, that's root 2 over 2. What's the cos of pi over 6?
We're
3 over 2. Then we are going to subtract the cos of pi over 4, which is root 2 over 2, times the sine of pi over 6, which is a half. This one we get root 6 over 4 minus root 2 over 4. Almost the same as the previous one, but subtractions in a different order up top. And remember, either of those answers will be fine.
Okay? You won't lose marks. But notice when we see, and this one is a pretty common one that you see on exams, a question like this. It was just on the January exam, the one that was written last week. There was one like this. Okay, yeah. No, you can't subtract radicals like that. Yeah.
So there's a couple of examples in radians.
Here's one with tan in degrees. Degrees is actually easier because it's probably easier to, can you think of two angles on the unit circle that add or subtract to get 75? Think of your angles on the unit circle. Think of the angles in quadrant 1, 30, 45, 60, then 90, 30 and 45.
So I can write this as tan 30 degrees
Plus 45 degrees.
and that's the tan sum. So if you go back to your formula, that's the same as tan 30 plus tan 45 all divided by 1 minus tan 30 times tan 45. Maybe off to the side here. Let's do these two before we. Tan 30.
So that's the y coordinate at 30. Divide the x coordinate at 30.
1 over 1. 1 over 2 over.
Should be 1/2
Or just.
divide root 3 over 2.
No, that doesn't work out to root 3.
1 over 3.
That works out to 1 over root 3. Okay, so we know that one. Tan 45 is easier.
Root 2 over 2.
Root 2 over 2, divide root 2 over
2, which is just plain old 1. So let's plug those in. Tan 30 is 1 over root 3 plus 1 all over 1 minus 1 over root 3 times 1. Well, and well, here, I'll just write this first. Obviously, 1 over root 3 times 1 so I get that.
That would be full marks minus a communication error of a half mark.
Because you haven't simplified it yet. So to simplify it, I would have to make common denominators.
Add the tops and the bottoms, or sorry, add the top, subtract the bottom, and then divide the 2.
Well, what's the lowest common denominator of root 3 and 1? Root 3. So I get 1 plus root 3, right? Same thing here, except I would get root 3 minus 1. Then we have to change it to a multiplication. Root 3's cancel out.
I can't cancel anything here because they're not identical.
So my answer is going to be this.
It's an awful lot of work for that extra half mark.
Because you get 3 out of 3 minus half here.
You get 3 out of 3 here. Every half mark counts, eh?
Okay, speaking of which, by the way, I'm going to
Give these exams back on Wednesday, and we're going to go through it, just so you know.
and I'll explain the whole communication errors thing.
Okay. Last type of question. You guys remember what I told you to do whenever you see a question that tells you about the quadrants?
When I see a question that gives me some trig ratios
And quadrants,
I'm thinking I need to draw some triangles on a coordinate grid.
And why did I do two? Because we've got two different angles, alpha and beta.
So this first one regarding angle alpha, I'm told that it's in quadrant 2 and that the sine is this ratio. Okay? So I need to draw a right triangle in quadrant 2. Remember, hypotenuse always comes up from the origin. And then vertical goes to the x-axis. Well, in order to find trig ratios, I need to know all these things. Otherwise, I can't do the trig ratios. Can you tell me any of the sides right now? Yeah. Sine opposite over hypotenuse, right? So remember, this is our reference angle. So this is 5.
The long one is good.
The hypotenuse is 13. And since I know 2 of the 3 sides, I can find the third one, x, by Pythagoras. Right, this is x. This, remember, this is x, y, and remember we always call the hypotenuse bar. So it's going to be x squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. X squared is going to equal 144. And x is going to be, be careful. Yeah, see, do it like this, you guys. Plus minus, write this. 12.
Because you can take the square root of 144.
But reject the positive. Why, Sonia? Because this horizontal side is in quadrant 2, which means that it's negative. Okay?
Because remember when we solve quadratic equations like this? Whenever we take the square root, we take the plus minus square root.
So that gives me information about alpha. What about this angle? Well, we're in quadrant 4. So I need to draw a right triangle like that. Okay, so this is alpha. This is beta.
X is 4.
So this tells me opposite over hypotenuse. Sorry, adjacent over hypotenuse. So the x, or the horizontal, is 4. And what's 5? The hypotenuse. Which means I have to find the missing y using Pythagoras. Remember, x squared plus y squared equals r squared. So that would give me 16 plus y squared equals 25. Y squared is equal to 9. Y is potentially what?
Oh.
Potentially. Plus minus 3, because it's plus minus root 9. But because we're in quadrant 4, y will be negative, so we reject the positive. And now we know this is 3. Why did I have to do all that? So I can do this. Is this the compressed form or the expanded form? Compressed form? It's the compressed form, which means I got to expand. What's sine sum? This is the sine sum I get. What do I got to do with the? It's going to be sine cos plus cosine.
Sine cos plus cosine. Look at your formula. Times sine cos plus cosine.
So the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Well, I know all these. I use my triangles, or I use the information in the question. What's sine alpha? What value is sine alpha? We're given it in the question. Not 5. Sine is a fraction. Yeah, 5/13. Times, what's cos beta? Yeah, we're given that. What's cos alpha? Now I got to go to my triangles. Here's alpha. What's cos alpha?
Negative 12 over 13.
-12/13. And what's sine beta?
Negative 3 over.
Oh, sorry, yeah, that should be negative. -3/5. Good. And now you got to multiply those and add them. So if I multiply these two together, I get 20/65.
Simple.
I'm not going to just like reduce.
Would you like to do that?
Yeah, you can do that if you want. But the only problem with that is you can't cancel out here. So you're going to end up with different denominators. The only reason I didn't cancel is because I know I'm going to have two 65s.
So negative times negative gives me plus 36/65. Yes, this can be reduced, but then you'd have to go back to common denominators anyway to add them. And when I add these two together, I get 56/65.
Okay. Oh, I really didn't do that in the spaces provided, did I? Oh, well.
So this is what I need to do for both of the questions. And text, I should actually put A here. That's it.
I need to do this for both of the questions. I need to set this up for both. This is part A, then we'll do part B.
Part B, we're not going to have to redo the triangles all over again. You are asked to find C, alpha plus beta.
I don't know one of those. There's no seek sum identity. So what do I do?
It works.
Yeah, don't I change this to 1 over cos alpha plus beta? That's in compressed form, so I have to expand it out, right? So this is going to be 1 over, well, according to your formula sheet, how is this expanded? Cos, cos minus sine, sine? No?
Yeah.
Yeah?
No? Why is nobody sure? We're reading the formula.
Cos, cos, minus sine.
Cos, cos minus sine, sine. cos alpha, cos beta, minus sine alpha, sine beta. And we can get all this information from up top. What's cos alpha? Cos alpha, negative 12 over 13. Remember, it's 1 over. Negative 12 over 13 times cos beta,
4 over 5.
4 over 5. Minus sine alpha
5 over 13.
times, oops, not root. Times sine beta. Okay. That gives me 1 over negative 48 over 65 minus negative 15 over 65, which actually turns to plus, doesn't it? So what's negative 48 plus 15?
33.
Positive or negative?
And what's 1 divide that fraction? It's the same as 1 times the reciprocal.
So it's 1 times the flip, which is negative 65 over 33.
What I wanted to do here is I just wanted to cover all the potential questions you could see. Okay, so if anything, the ones on the second and third page that we just did will be the most common ones that you would see. Okay, the one on the first page maybe doesn't happen very often. The one on the second page is probably the one that happens the most in this topic. Okay.
Okay,